Good morning, everyone. Today, we shall be discussing zeros and poles. Once again, today, we shall be discussing zeros and poles of a mathematical functions, especially fractional function in an algebraic formation. Our example today, let the function be fx, considering the function fx, which equals x raised to the power 3 minus 64 all over x raised to the power 2 minus 4x minus 21. From here, we can deduce or find our zeros and poles. So, to find zeros and poles, first of all, we need to know that zeros are defined when the numerator of a fractional algebraic form are 0. Also, poles are defined when the denominator of an algebraic fraction equals 0. So, let's go. From there, we can define our zero when the algebraic formation of the numerator equals 0. So, that tells us that x raised to the power 3 minus 64 equals 0. Also, from there, we can deduce that by the time we take 64 to the other side, then we say x raised to s cubed equals 64. Then from there, we find our x, which is x equals cube root of 64. Therefore, x equals 4. So, the formation of our function here tells us that whenever x equals 4, then we have zeros. Let's move on. To find our poles is defined whenever denominators equal 0. So in order to make our denominator equal 0, we take the denominator of our function over here, which is x raised to the power 2 minus 4x minus 21 equals 0. Then we can see that this, our denominator, is quadratic in formation. From there, we can make a factorization method by deducing that x raised to the power 2 minus 4x minus 21 equals 0. Then from there, we can make it x raised to the power 2 plus 3x minus 7x minus 21 equals 0. Then we factorize the broad bracket. Therefore, we find x raised to the power minus 7 in bracket x plus 3 in bracket equals 0. From here, we can find the x, which equals 7 or minus 3, which is the entries for our poles. Thank you, everyone.